All right, let's introduce Lab 3. You guys are ready for it? So let's go to that right up. And this one is going to be about two separate things, but still kind of similar. Structs and strings. All right, so let's talk about this. It's all about memory. So get that starter code wherever you want to get it. And these will be the files that you see. And yeah, let's talk about it. So the first part of the lab is going to be about structs. So let's look at this point3d driver.cpp file. It creates a point3d struct and a function on those points. All right, at least declares it. Point3d, it was the driver one, right? Yeah. So here, here is a point3d struct. It's meant to represent a single point in three-dimensional space. So you have x, y, and z coordinates for that thing. And then here's a point3d add function. If you are given a pointer to one point and a pointer to another point, I guess pun intended, I would like you to give back a third point that is the sum of those points, if that makes sense. Okay, so I'll show that to you in a second. So let's see. Yeah, every point3d represents a point in space, so like the point 2, 3, 4. You could store it as a point3d by putting x equal to 2, y 3 into y, and then 4 into z. All right, your job in assembly is to make this point3d add function, the one that I've declared here, that takes two pointers to point3ds. All right, so you're getting the address of two separate point3ds, and you're going to sum up those points that you're given into a new point3d on the heap. So you have to use malloc. I got to figure out how big is a point3d, how many bytes does it need to take up, right? And so, for example, if you are given pointers to like a point 1, 2, 3 and a point 2, 3, 4, the idea of adding together the points is just like add up the x coordinates, like the 1 plus 2, make a brand new point on the heap with the x part set to 3, a new point on the heap with the y part set to 2 plus 3, so 5, 3 plus 4 for 7, so for that z. And so that's how you're going to create it. Right? That's what it means to add 2 points, let's say. And yeah, that's the code that you're going to be writing in assembly. So I've made this little driver file that calls your function, all right, a bunch of times, or just once at least. Every time you run it, it runs it, does it manually, and it's random. So isn't this cool? So I'm going to make a bunch of random point3ds, and so as you rerun this program, this driver program, you can test your code more and more, because it's going to make brand new points. And so it's going to call your function, make sure it gets back a new point, it'll print them out so that you can check and see if it was all working, and then I'm checking for you, all right? And I also make sure it was made on the heap by freeing it. So like, get all that to work. And of course you can make your own files or add to this one to like print out the size of stuff. Like if you can't figure out the offsets, that'll work. You can also use GDB for that. But yeah, your goal is to go into this point3d add.s, and your job is to implement this function. So you've been given 2 points, point3d p1, so that's in x0, right? That's your first argument, and then x1 is your second argument. You have to go into this memory, get the x, get the y, get the z, and figure out how to make a brand new point3d of the right size on the heap, go into that memory and store the summed x, the summed y, the summed z, all right? And you got to return this address as you finish, okay? So that's going in x0, remember, okay? So you got to return that new point3d on the heap, and this is what it means to add them up, okay? Add up the corresponding coordinates of each, all right? So here's kind of how it works when you compile it with the makefile, and then you run it. So like here are the 2 random points, and here it's adding them. And you should see that like it added them correctly. It's x space y space z for each. And that's different every time because it's random. So that's pretty cool. All right, so that's the first thing that you're going to do. Get some practice with like your loads and your stores and your memory manipulation. And then the second part of the lab will be it's like a S2I or A to I library function, if you've used that before. It's converting strings to integers. All right, so again, I've made a driver file that randomly makes some numbers this time. And your job is to make a function. If I go to that file, your job is to make a function that has this signature. It takes a C string and it converts that string to an int. Isn't that cool? So it's time for you to learn how to do that. All right, so I'm going to practice. I'm going to force you to practice with random integer strings. I'm going to call your function and make sure it matches what the library should be doing, right? Make sure it does the right thing. And so, yeah, you're converting from strings to integers, all right? And so you're going to be implementing this function in this file, string to integer.s. And Yeah, remember that you have one argument and x0 is the C string, and you have to return an int, so that's going in W0. All right. So let's talk about how in the world do you convert a string to an integer. All right. The secret is you're going to loop through this string. Like let's say you were given the string 1, 2, 3 as a C string. Here's what you do. All right, let me draw. You are going to start, like here's the string 1, 2, 3. You're going to read each character of that string. Remember that there's also a secret null terminator like at the end of the string. That's going to tell you when you're done looping through all the digits. All right. So your goal, the idea is that you need to set up like get a register or a variable somewhere. It's called your accumulator. You're going to start that at 0 because you're going to accumulate a value. That is going to be the final integer result. And it starts at 0. All right. And your goal is to read one by one each of those characters. The first time you're going to read the one character. You're going to see it. It's the first character in the string. You're going to load a byte, right? Read that one character. And then you're going to put that into the accumulator, right? You're always going to shift over the accumulator, like multiply it, and then, so it's still 0, and then you add in the 1. Okay, so now it's holding 1. Does that kind of make sense? And then you're going to advance your pointer into the string. So now you're going to look at the 2. It's going to be a loop until you're done. So now you're going to see the 2. All right, look at the second character, see it's a 2. Convert it to the number 2. Oh, sorry, I forgot to say that, first of all. This one digit, the ASCII code for 1 is not 1. Excuse me. Man, ASCII. The ASCII code for 1 is, what in the world is it? It is 49. So that has nothing to do with the number 1. You have to convert the character for 1 into the number 1. And here's how you do that, all right? Do you see that if you have the character for 1 and you subtract it from the character for 0, which is right before it, that's 48. This is like 49 minus 48 at that point. Do you see how that will give you the actual number 1? That's how you convert it to the number 1. All right, so whatever digit character you're looking at, get it into a register, subtract it from the ASCII code for 0, and that'll always give you the right digit. The digit as an int, all right? So that's how you do that. So you're converting, I forgot to say it, convert that character to the number 1 and put it in the accumulator, all right? And then you advance your pointer into the string. So now you see the character for 2. You have to convert it to the number 2 by subtracting from the 0 character. Okay, that's important. And then you're going to, all right, you need to convert this into, like, it's 1 right now, you got to make it 12 because that's what you've seen so far. So how do you convert this to 12? Well, the first thing you do is you shift over your accumulator, right? So make it hold 1, 0. Do you see what you need to do to make that happen? And then you can add in your 2. Now you have a new place for the 2. So now make it 2. So that's kind of the loop that you're going to do. So now you see the 3, right? You see the 3 character, convert it to the number 3 by doing the special subtraction. So now you have a 3. You have to shift over your accumulator, make it 120. Do you see how you'll do that? And then add in the 3, 123, all right? And then you know you're done when you hit that null terminator character, all right? The null terminator character is that \0. For a weird reason in assembly, you can't just like check with, I can't like move into W1 $ quotes \0. For some weird reason that won't work. So you just have to say number 0. All right, so because the ASCII code for the null terminator character is 0. So just move 0 into the register and like that's what you're comparing against. So now compare W1 with whatever register that you were storing your character in. And that's how you know to stop. Okay? So that's gonna be the process. Do you see how that's gonna be a loop? I highly encourage you, if you don't fully see how to do this in assembly and like that's too hard, do it in C or C++ first. Do this process, like implement the actual function. You have the, like, do it in this file if you need to. Oops. This file. Do it in this file if you need to. And then like translate it to assembly after that. That'll make it easier on you maybe. Okay? But yeah, eventually you're going to put it here because this is what you're turning in. You got to turn it into assembly. And yeah, I have made that driver file create a random string with some random characters in it. And then I'm going to print out like what your function gives back. And it should match what the library function gives back. It's always going to convert it to the same integer. All right? So it's a different number each time. So I encourage you to keep running your program after you compile it with the makefile. And yeah, that's the process. Do you see how you'll implement a loop to do that? And that's going to help you with, like, you're going to have to use load byte a lot. You're going to have to use some saved registers. It's good practice with everything we've been doing. All right. So that is the next part of your lab. So do yell at me if you have any questions about that. But I think that's all that I wanted to talk about. Those are the two things that you're implementing. The only place that you can write code is in the files that you're turning in. So make sure to keep that in mind. Don't add any special things into the driver files because you're not turning those in. And the AutoGrader will be using the original versions of those files. All right, so you're only turning in the files that you're supposed to mess with, those assembly files. And the rest is just the default ones from before. So yeah, that's how you turn it in. The string to integer one is worth twice the credit. Okay. Because it's fancier. It takes more time. But yeah, that's your lab 3. I think that's all that I wanted to say about it. So please yell at me if you have any questions, and I'll see you in the next video.